Welcome to Study Loop.
This is chapter 37, problem number 26. We're given the mass of a baseball and we are given the acceleration of the baseball. We want it to be 1 meters per second square. And for a series of initial speeds that are given to us in part A, B, and C, part being 10 meters per second, B being 0.9 C and 0.99 C, we're asked to calculate the force that it takes to accelerate this baseball to the given value here. Now, since part A is not dealing with the relativistic velocities, F is really straightforward, right? It's m times A. So m is 0.145 kilograms, and the acceleration is 1 meter per second square. So as an answer to part A, we have 0.145 newtons. Now in part B, as you can see, now the speed is much higher. So let's answer part B here. When that's the case, on your textbook, you can go and find equations 37.32 and 37.33. You're going to figure out that the relativistic force is going to be depending on whether or not the acceleration is in the direction of the velocity vector or it is perpendicular with respect to the velocity vector. We have different equations for each. So if F and V vector are along the same line, then we have F equals cube of gamma factor times m times A. If F and V are perpendicular, then we actually have gamma factor m times A. So in part B, since it's given to us that they're in the same line, then this is the equation that we're going to use for both part B and C. Okay, so going back to part B, now I'm answering part B. Part B would be F equals gamma cubed m times A. Now, the gamma factor is, 1 over square root of 1 minus V in this case is 0.9C. 0.9C squared over C squared. But we're going to take the cube of this. 1 cube of 1 is 1. And we're going to take the cube of denominator then. M is going to be 0.145 kilograms. And the acceleration is again 1 meters per second square. So if you do everything correctly, then the force is going to be found as 1.75 newtons. Now we're going to do the exact same thing for part C, still where the acceleration and the velocity are along the same line, so which means the force is going to be along the same line as the velocity vector. So we're going to use the same equation. C F equals gamma cubed m times A. Only this time we have a different gamma factor, right? Because the magnitude of the velocity is different now. 0.99C squared over C squared cubed. The square is inside the square root. M is still 0.145 kilograms. And we have the acceleration, 1 meters per second square. From here, we find the force to be 51.79 newtons. Now, in part D, we're asked the same parts as A, B, and C. Now, this time, F is actually perpendicular with respect to the velocity vector. Now then, the equation to use in this part is gamma m times A, except for part A. Again, in part A, remember what the speed was. It was 10 meters per second. So for that one, for part A, our answer is not going to change. It's still m times A, right? So it's still 0.145 newtons. However, our answer to part B is going to change because now we have gamma, not cubed, but only gamma. So F equals gamma m A. 1 over square root of 1 minus 0.9 c squared over c squared times 0.145 kilograms times 1 meters per second square. So our answer to part B this time is going to be 0.333 newtons. Using the same formula, our answer to part C is also going to change. 1 over square root of 1 minus 0.99 c squared over c squared. M is 1.145 times 1. Now answer is 1.03 newtons. So you can see how much they change when we have our acceleration perpendicular to the velocity.